So they should be able to hear you and they should be able to see you now.
All right. Hello, everyone.
Yes, welcome. Hi, welcome to our AMC 8 live solve. So this year we're going to be doing 2002, and there's going to be two of us as per our signature daily challenge style. So I'm going to go ahead and introduce my co-TA today. So Karthik is from Florida, and he is a 2022 MOB qualifier, and he has represented Florida at Math Counts Nationals. Other than math, he also enjoys doing puzzles such as Sudoku and Philomeno and other puzzles like that.
Yeah, thanks so much. Yeah, and I'll be teaching with the amazing Angela Guo, who is a 3-time Amy and Math Prize for Girls qualifier, and she is a Math Counts State Countdown second place, which is like second place in the state, which is amazing. And her favorite brand of toothpaste is Crest because it actually cleans your teeth without a bad taste. All right, and so with that out of the way, now we're gonna start going over the way that we're gonna be going over the AMC8 problems. So basically how this is gonna go is that we're not gonna be displaying the problems on the screen. We're gonna, you guys can look at the problems yourselves at the on the live website. And so we'll be reading the AMC8 problems out loud, but yeah, so that's how we'll be going over each of these AMC8 problems. So we'll just explain it on our slides over here.
Awesome, yeah. And for those who may have just stumbled in or not know too much about AMC8, right? It's this contest run by MAA, and it's pretty famous nationally for challenging mathematically talented young minds. And it's specifically designed for 8th graders and below. So maybe some of you guys have taken this, but it's a really great contest to try out.
Yeah, it has a lot of challenging problems. 25 problems in 40 minutes. Yeah, and so so that's about the AMC8. And then also, as you guys are discovering, you see this box down here, right? This box is what's called as the chat relay. And so yeah, so you can type if you look at the chat relay link, you can type into, or sorry, if you message chat relay, then you can see your we can see your messages down here. And so that'll be a great way for you guys to communicate your ideas and communicate with other people as well. And so we recommend that you use this rather than just direct messaging us or something like that.
Yeah, and thanks to our moderators for putting the link into the Zoom. So hopefully you guys can access the problems there. And one last thing is that this session will be recorded, so please change your Zoom names into something that is not your real name. Yes, as the moderator has just said. So that way we can protect your identity as well as release this to everyone who wants to enjoy our AMC8.
Yeah. So with that, we can start on the questions. So hopefully you guys have opened the AMC8 contest as the moderator has just linked. And so you guys can follow along with us about all of the problems. And so let's start with number 1. So question 1 says, Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar and twice as much sugar as lemon juice. He uses 3 cups of lemon juice. How many cups of water does he need? So the question here, we're given that Luca has 3 cups of lemon juice. So 3 cups of lemon juice. And so we have 2 other things that we want to find. We have the amount of water and the amount of sugar. And so let's see here. So we have water, which we don't know, and we have sugar. So basically, we can use the ideas or the statements in the problem to try and figure out how much of each there are. So yeah, so does anyone have any ideas on how we can use the statements to try and figure out how much water and how much sugar we have? So you can type your ideas into chat relay. Oh, wow. So Anonymous Buffalo gives a really good explanation. So Anonymous Buffalo says he needs 3 cups of lemon juice and twice. So in the problem, it says he needs twice as much sugar as lemon juice. And so twice as much sugar as lemon juice, as Anonymous Buffalo says, is since we have 3 cups of lemon juice, the amount of sugar is twice as much. And so twice of 3 is just multiplying it by 2, which is 6 cups. So we know that we have 6 cups of sugar. So this is 6 cups. But sugar isn't exactly what we want here, right? The question asks how many cups of water does he need? And so in order to figure out how many cups of water, well, as a lot of you guys are saying, you need 4 times as much water as sugar. And we just found the amount of sugar that we needed. And so we need 4 times as much. So if we have 6 cups of sugar, we need 4 times as much for water, which is 6 times 4 or 24 cups. So this would be 24 cups. And this corresponds to answer choice E.
Awesome, yeah, and I agree with Anonymous Buffalo. 6 cups of sugar is a lot of sugar.
Yeah. Yeah, it's
All
a very interesting lemonade.
But yeah, nice job, everyone. So now we're going to move on to question 2. So question 2 reads, 4 friends do yard work for their neighbors over the weekend, earning 15, 20, 25, and 40, respectively. They decide to split their earnings equally amongst themselves. So in total, how many dollars will the friend who earned $40 give to others? Awesome. Yes. Thank you, Anonymous Buffalo, for putting the question. So when we look at this problem, the first thing I would do, and as Sepioloidia linonata, wow, that's a nice name, put in the chat, right? We would want to calculate how much it is if we do indeed split it. So just summing up all of the terms, we'll get 15 plus 20 plus 25. So 15 plus 20 plus 25 plus 40, that will give us 100. And if we do 100 divided by 4, we find that everyone should end up with $25. Okay, so okay. So if we end up with 25, that means our person with 40 will end up giving 40 minus 25, which is $15. So that would correspond with option C. Yeah, awesome job, guys.
All right, so that was a really good explanation. And now we're going to move on to question 3. So question 3 says, Carrie has a rectangular garden that measures 6 feet by 8 feet. She plants the entire garden with strawberry plants. Carrie is able to plant 4 strawberry plants per square foot, and she harvests an average of 10 strawberries per plant. How many strawberries can she expect to harvest? So in questions like this, where you have like a lot of different types of information, one good thing is to try and organize your information. So the first piece of information that we have is that the garden is in the shape of a rectangle, and specifically, we know the dimensions of this rectangle. So this rectangle is a 6 foot by 8 foot rectangle. And we're planting strawberry plants throughout this rectangle. And so in order to find out how many strawberry plants, we look at the next piece of information. If Carrie is able to harvest 4 strawberry plants per square foot, so in 1 square foot, she is able to harvest 4 plants. So what this means is that for each square foot of area, then she can harvest 4 plants. So what that means is that we have to find out the area of this rectangle. And the area of a rectangle is length times width, or length times height. And so 6 times 8 is 48 square feet. So that's the area of the plot of land. And so if we know 1 square foot gives us 4 plants, well, how many plants does 48 square feet give us? Well, that would be 4 times 48 plants. Because we're multiplying by 4 from going 1 to 4, and so we'll have to multiply by 4 from 48. And 4 times 48 is equal to 192 plants. But we're not quite done. And I notice a lot of you guys are already saying the answer, and we're almost there. So notice that the final piece of information is, on average, she'll get 10 strawberries per plant. And so we know that there's 192 plants, which means that if we're getting 10 strawberries per plant, that would lead us to 992 times 10 strawberries. And so this would be 1920 strawberries. And this corresponds to answer choice D.
Awesome. Yeah, I saw a lot of people getting in the chat really early. So great job there, guys. Okay, on to question 4. Ooh, this one seems a little complicated with the diagram, but I'm sure we can get it. So it reads, 3 hexagons of increasing size are shown below. Suppose the dot pattern continues so that each successive hexagon contains 1 more band of dots. Okay, so how many dots are in the next hexagon? Okay, so to solve this problem, I think we need to try and find a pattern. Looking at the first one, we're simply just given 1 dot. But the next one, this band is really interesting because we have kind of this hexagon with 6 more dots. So I'm going to add 6. And then, what do we see about the next one? So someone has mentioned, right, we're increasing by 6 here. What else? Ooh, okay, I see an idea from Anonymous Buffalo that's 1 plus 6 plus 12 plus 18. I also saw the same thing from Scipioloidia. I'm going to shorten your name, sorry. But yeah, so we kind of see 1 plus 6 plus 12, and that makes us curious. Maybe the next one will also have another band of 6. And we can kind of see why this is true. Suppose we did have another band. So I will extend only one side. And we notice here that this has 2 dots in the middle now when we expand the band. So we can expect that on each side, we're going to have 2 dots plus the vertices. So something that looks like this. And if we did have 2 dots, that would mean we added 6 from the original 1 dot in the middle, right? Originally, this band previously had 1 dot in the middle, and we can also see that if we go in, this has 0 dots in the middle. So this helps us confirm that our expectation will be exactly 3 times 6 dots on the outside, which will be 18 for the next band. So we're going to have 1 plus 6 plus 12 plus 18 for our final diagram. And a lot of you have already helped me evaluate this, which will turn out into 37. And that will be answer choice B.
All right, so now we can move on to question 5. And so question 5 says 3/4 of a pitcher is filled with pineapple juice. The pitcher is emptied by pouring an equal amount of juice into each of 5 cups. What percent of the total capacity of the pitcher did each cup receive? So notice that in the original pitcher, so let me attempt at drawing a picture of a pitcher. All right, so this is 75% full. And where did I get 75 from? Well, it's in the problem it says that 3/4 was full. In order to convert 3/4 to a percent, which is what we need in the problem, we multiply this by 100. And so 3/4 of 100 is 75. So our pitcher is 75% full, and we now pour this into 5 cups. So when we pour it into 5 cups, we want to find out what percent of the total capacity of the pitcher did each cup receive. So we are splitting 75% of a pitcher across 5 different cups. That means each pitcher will receive 75 divided by 5% of the whole entire pitcher. And so this will be 15%. And this is answer choice C.
Great. Okay, moving on to question 6. Question 6 is kind of a logic problem, so let's see if we can puzzle it out. It reads, Aaron, Darren, Karen, Marin, and Sharon wrote on a small train that has 5 cars. Okay, so we have essentially Aaron, Darren, Karen, Marin, and Sharon. Awesome. And we're given that Marin sat in the last car, Aaron sat directly behind Shannon, Darren sat in one of the cars in front of Aaron. Okay, and at least one person sat between Karen and Darren. Ooh, that's a lot of information. Who sat in the middle car? Okay, so let's see. Let's first draw out kind of like a hypothetical train. And what we're gonna do is we're gonna label a front and the back. So I'm gonna label here the left side, or at least my left side, the front, and over here as the back. And let's just go through each of the conditions that we were given. So we had that Marin sat in the last car, and we can easily just place Marin here. Okay, so Aaron sat directly behind Sharon. That means that we'll have some situation that looks like this. Sharon and then Aaron. Kind of like a group, right? So either Sharon sits in the first place, the second place, or the third place, but Sharon cannot sit in the fourth place because Aaron has to be directly behind. Okay, we also have that Darren sat in one of the cars in front of Aaron. So that means our situation looks somewhat like this. We're not sure if someone is sitting between Darren and Sharon right here, but we know that this is the general. Ooh, okay. And one last condition is that at least one person sat between Karen and Darren. Awesome. So this helps us solve our whole lineup here, because originally we weren't sure if someone sat between Darren and Sharon, but since Karen is the only person left, and we have to place Karen not next to Darren, that means Karen must be over here, right? So we can finish our lineup and see that the order will be Darren, Sharon, Aaron, and Karen. Okay, ooh, that's a lot of names, but we're able to find the middle one and say that it is indeed Aaron, which happens to be option A.
All right. So now we can move on to question 7. So question 7 asks, how many integers between 2020 and 2400 have 4 distinct digits arranged in increasing order? For example, 2357 is one such integer. All right, so let's see. So our bounds are somewhere between 2020 and 2400. So, and we're trying to look at all the integers in between. And so notice that after the first digit, the second digit has to be greater than 2, because if it's not greater than 2, then we won't satisfy this digits are increasing condition. And so if we have digits that are at greater than 2, then what we have to have is either we can't have 2, 0, right? Because 0 is less than 2. We can't have 2, 1, and we can't have 2, 2, because 0, 1, and 2 are not greater than 2. So we either have to have 2, 3 followed by 2 digits, or 2, 4 followed by 2 digits. So let's look at this 2, 4 case. So in this 2, 4 case, well, the only number that can start with 2, 4 is 2400, because that is our upper bound. And any number less than that would have either a 2, 3 or lower. And so 2400, does that satisfy our increasing digit condition? No, right? Because the 2 zeros are both less than 4. So this does not contribute anything. And so now we know that any digit increasing number in this range must start with 2, 3. For the remaining 2 digits, we have to pick from some selection of 4, 5, 6, 7, 8, or 9. Because we notice our remaining two digits have to be greater than 3. And these are the only digits that are greater than 3. And so notice that we have to pick two digits. We have to pick two distinct digits because these two digits cannot be equal, right? Because it's strictly increasing as you go from left to right. And so notice that if you picked any two digits, like let's say 6 and 5, right? And so if we pick 6 and 5, the order that those digits have to be placed in is fixed. So if we pick 6 and 5, we would have to use 2, 3, 5, 6, because 2, 3, 6, 5 will not work. And so what that means is that our problem has now turned into how many ways are there to pick two digits out of these 6 digits? And well, this is a pretty famous problem in combinatorics. And this is what's known as the choose function. So in this case, it would be 6 choose 2. And so the way that we can evaluate this is in order to choose two numbers out of 6, where the order does not matter, we can first pick our first number. Let's say we have 6 choices for our first number. So let's say we pick the 4, right? That was one of the 6 choices. And so once we pick the 4, we can no longer use it. And so now we have to pick one of these 5 for our second choice. And so we have 5 choices. Let's say 6 was our second choice. And so once we picked 4 and 6, we are done. However, notice that when we pick 4 and 6, as some of you guys are noticing already, if we pick 4 and 6, that's the same thing as picking 6 and 4. And so we're going to be double counting here, because for any pair, picking A and B is going to be the same as picking B and A. And so what this means is that we're going to be counting every pair of digits twice. And so we have to divide by 2. And so now we've accounted for every pair exactly once. And so what this means is we are left to evaluate this. 6 times 5 over 2. 6 times 5 is 30. Divided by 2 is 15, which is answer choice C.
Awesome. Nice. Now we're going to go on to question 8. So Ricardo has 2020 coins, or 2020 coins, some of which are pennies, the rest of which are nickels. So he has at least 1 penny and at least 1 nickel. What is the difference in cents between the greatest possible and least possible amounts of money that Ricardo can have? Ooh, someone wants to explain. Okay, why don't you go ahead and unmute and let's hear your explanation. Oh no. Okay. Maybe we can change a setting. Is there a setting?
I'm not sure.
Okay, that's okay. In that case, maybe start typing out your solution while we start explaining. Ooh, Warrior Cats also wants to do it. Okay, let's see. Yeah, so why don't both of you guys start typing solutions, even if it's just sentence by sentence. Yeah, unfortunately, we're unable to allow you guys to unmute right now, but that's okay. You're still very welcome to share your ideas. And let's get started. So if we want to maximize the amount of money, we have to choose between pennies and nickels. And I don't know about you guys, but every time that we replace a penny with a nickel, we actually increase by 4, right? So every time we want to maximize, we just want the maximum amount of nickels, because that will help us achieve more since we're replacing it with 4, right? So since we have 2020 coins, that means that they should all be nickels, right? Well, this isn't really the case here because remember the problem said we must have at least 1 penny. That means that we can only have 2019 nickels, and then one of them has to be a penny. And similarly, we can reverse this logic and think about what is the minimum. So for the minimum, we'll have, awesome, 2018 times 1 or 5 plus 6. Awesome, yeah, I totally agree. So if we had 1 penny, or we had 2019 pennies, sorry, and 1 nickel, then this would be our minimum. And as Panda A put in the chat, right, this is also equivalent to 2018 times 1 plus 6, where this 6 just encompasses our whole nickel and penny restriction. All right, so let's try and find the difference of these two expressions. If we subtract them, we'll get 2019 times 5 minus 1 plus 1 minus 5. Awesome. So this will give us 2019 times 4 minus 4, which is just 2018 times 4. Okay, let's quickly do that on the side. So 2018 times 4, 708. Awesome. And this will correspond with answer choice C.
All right, so now we can move on to question number 9. So question number 9 says that Akash's birthday cake is in the form of a 4 by 4 by 4 inch cube, as shown here. The cake has icing on the top and the 4 side faces, but no icing on the bottom because, well, getting icing on the bottom of a cake is pretty hard. And suppose the cake is cut into 64 smaller cubes, each measuring 1 by 1 by 1 inch. So as you can see, like this cake is cut into a bunch of different smaller cubes. And we want to figure out how many small pieces will have icing on at least 2 of the sides. All right, so let's do some coloring here. Let's see what the icing looks like. So if we try and color in, like for example, this entire side will be shaded, the top will be shaded, and the sides will be shaded. What you can notice is that any cube in the center of a face right here, or actually first off, notice that there will be cubes in the interior that won't have any icing at all, right? If you have cake in the interior, you can't give it icing without cutting into the cake. And so also notice that in the center of a face, so this 2 by 2 square right here, that will only have one side of icing. So we're looking at things that have 2 sides of icing. So any of these like central squares will only have 1 side of icing. So now the question is which cubes will have 2 sides of icing? So this cube on the bottom corner here will have 2 sides of icing. So it has 2 open faces. And similar to these edge cubes will also have 2 sides of icing. So on any edge column like this one, there will be 3 cubes that have 2 sides of icing. So namely these 3 cubes. So we have 3 times, how many columns do we have? We have 1, 2, and then notice on the back we have, if you visualize, there would be another column and then on the back column over here. So we'll have 4 vertical columns of cubes with 2 sides of icing each. And so let's see if there are any more. So notice on the top face, these 4 corners up here will have 3 sides of icing, one from the top and one from the 2 sides. And so we want only cubes that have 2 sides of icing. And also notice that any cube in the center of the top face will only get 1 side of icing. So the only cubes that we're looking at now are the edge cubes. So for example, if you see these 2 cubes right here, and these 2 cubes on the side, and these 2 cubes on the back, and these 2 cubes on the right side. So those 8 cubes will get 2 sides of icing, one from the top and one from the side. And now we've considered every cube, and we found out the total count, and we see that this total count comes to 3 times 4, which is 12, plus 8 is 20. And this is answer choice D.
Nice. So moving on to question 10. So the problems are getting a little bit trickier, but I think double digits, nothing to worry about so far. So Zara has a collection of 4 marbles, an Augie, a bumblebee, a steely, and a tiger, which I'll just abbreviate as A, B, S, and T. And she wants to display them in a row on a shelf. She does not want to put the steely next to the tiger. Okay, how many ways can she do this? So just as a reminder of how we should order things, how many ways are there to order these 4 objects without any restrictions? Can someone maybe help us out in the chat? How many ways can we put A, B, S, and T in a row without considering any of the restrictions in the problem? Awesome, yeah. So someone put in the chat 24. If we had 4 positions, we have 4 choices for the first one, 3 for the next one, 2 for the third one, and finally, we only have 1 place to put the last one. And this will give us 24. And right away, we can kind of just eliminate option E, right, 24, because it didn't consider our restriction. Awesome. Thanks, guys. So now let's kind of see what we can do with this restriction. Ooh. Whoa, okay. Someone put a huge explanation in the chat. So, yes, I agree that we can't ignore the constraint, and let's see how we can deal with that. I think what I would like to try is something called complementary counting. So let's just kind of be rebellious in our moment here and put S right next to T. And after that, we still have to group these together, but we still have A and B. So how many ways essentially are there to arrange these 3 objects and arrange S and T within the group? So how many ways can we arrange the 3 objects and order S and T within the group? Awesome, so arranging 3 objects, we get 3 factorial, or 3 times 2 times 1, which is 6. And finally, if we want to arrange the group of S and T, because being next to each other doesn't mean it has to be S and T. It could be T and S. Therefore, we have to multiply 6 by 2. And we'll get that 12 of the options out of our total 24 don't actually work. So the number of ways that we can do this such that S and T are not next to each other is just total minus when they are next to each other. And this will give us 12 ways, which corresponds to option C.
All right. So now we can go on to question 11. So in question 11, we have this graph here, and we're given Maya and Naomi are heading to the beach 6 miles away. So as you can see, the top of this graph is 6 miles. So Maya decided to bike while Naomi decided to take a bus. And the graph shows their journey. And if you notice that they stop at some points, which indicates this flat line here, they weren't moving. And what is the difference in miles per hour between Naomi's and Maya's average speeds? So the key word here is average speed. And so average speed indicates this average speed over the entire journey. And so what this means is that we take, to calculate the average speed, we take the total distance, because remember, speed is equal to distance over time, and we divide this by the total time. And this is the average speed taken across the entire journey. And so now, as a lot of you guys are saying, Naomi has traveled 6 miles, which is her distance. So let's label this as N. So she travels 6 miles. And well, how long does she travel for? Her time? She ends, if you notice, exactly on the 10-minute mark. So we could use 10 minutes, but notice that the problem asks us for miles per hour. And so maybe it'll be easier if we convert the 10 minutes into hours. So notice that 10 minutes, 60 minutes is 1 hour, so 10 minutes will be a sixth of an hour. So we'll do 6 miles divided by a sixth of an hour. And, well, 6 divided by 1/6 is the same thing as multiplying 6 by the reciprocal of 1/6, which is 6. And so this will be 6 times 6, which is 36 miles per hour. And now we can do the same thing with Maya. So Maya, she also travels 6 miles, but the time she takes is different. She takes 30 minutes. So 30 minutes is half of an hour. And so 6 miles divided by 1/2, that's the same thing as 6 times the reciprocal of 1/2, which is 6 times 2. And 6 times 2 is 12. So we have 36 miles per hour and 12 miles per hour for the average speeds. And now the question asks us, what is the difference in miles per hour between their average speeds? And so we know that their average speeds are 36 and 12, so the difference will be 24 miles per hour, which is answer choice E.
Great. On to question 12. So this question reads, for a positive integer n, the factorial notation n factorial represents the product of integers from n all the way to 1. So what value of big N satisfies the equation 5 factorial times 9 factorial equals n times 12 factorial? Okay, wow, there seems to be a lot of interesting symbols here, but I'm sure that we can figure out what these mean based on the information that they told us. So right away we can see that 9 factorial is something that will be smaller than 12 factorial. Someone gave a great idea that it can't be 11 because 11 doesn't appear on both sides. And I agree. We can easily see that answer choice B will not be correct because we don't see 11 part of any side. Okay, and we got a great suggestion from the Warrior Cats that we can divide both sides and cancel the factorials. So I totally agree. One thing to notice is that 12 factorial is 12 times 11 times 10 times 9 factorial. 9 factorial is just 9 all the way to 1. Awesome. So if we do divide both sides by 9 factorial, we'll get 5 factorial equals n times 12 times 11 times 10. Awesome. Okay, now we just need to figure out what 5 factorial is. So let's try and figure this out. Okay, one small issue. So the problem statement originally was actually n factorial times 12. So sorry guys, that was a misstep on my part. So let's actually change the expression. So the expression itself was n factorial times 12. Awesome, okay. There we go, now I have the right problem statement. So from this, we need to find n. N seems like a big number, and just looking at this again, I would try and deal with the 5 and the 12 first, mostly because I know those will be smaller numbers. So yes, awesome. And 5 factorial, we can easily expand to be 5 times 4 times 3 times 2 times 1. And this will turn out to be 120. Awesome. And 120 is a number that we kind of see over here, right? We see the 12 and we see the 120. So this kind of helps us confirm that maybe we should divide both sides by 12. So let's do that. And 12, not 12 factorial. Once we do that, we see we have 120 over 12 times 9 factorial over 12, which equals 10 times 9 factorial, which equals n factorial. Okay, so looking at this and corresponding the terms, as WordCat has pointed out, we can just declare that n equals 10 because we have the product of numbers from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, which is in fact 10 factorial itself. So then the answer would be option A. Awesome.
All right. Yeah. So now we can move on to question number 13. So question 13 says Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange socks. After adding more purple socks, Jamal noticed that there is now a 60% chance that a sock randomly selected from the drawer is purple. So how many purple socks did Jamal add? So one thing to notice in this question is that we only care if a sock is purple or not purple. So the fact that there's both green and orange socks doesn't really matter. The green and orange socks in this problem are treated exactly the same way. So we can note down the information originally in the problem by saying that there are 18 purple socks, which I'll call PS, and then 6 plus 12 for the orange and green, which is 18 non-purple socks, which I'll say NPS. And now Jamal adds some socks, some purple socks. So let's say he adds X purple socks. And now the percentage of socks, the percentage of purple socks is now 60% because the probability that he pulls a sock purple is equal to the percentage of the total socks that are purple. So this is 60% and this is 40%. And so now if we add these two, that means in our new drawer, we'll have 18 plus X purple socks. And here we'll still have 18 non-purple socks. So notice that if we have 18 plus X purple socks and 18 non-purple socks, this has to be the same ratio as 60 to 40 because 60% represents the total percentage of purple socks there are, and 40% represents the total percentage of non-purple socks. And so in order to do this percentage, we have to have the same ratio. And notice that we can simplify the 60-40 ratio into a 3-to-2 ratio. And so we have a 3-to-2 ratio of purple socks and non-purple socks in our final drawer. So notice that if 18 non-purple socks corresponds to 2 in our ratio, then we have to scale up this ratio by a factor of 9, right? Because 2 times 9 is 18. So in order to keep the ratio the same, we have to scale up by the same factor on the purple socks. So we're multiplying by 9. And so 3 times 9 is 27. So the new number of purple socks has to be 27. And so if we have 27 total purple socks, and we know that this is 18 plus X, where X is the number of purple socks Jamal added, then we have to have, we can subtract 18 on both sides to get 27 minus 18 equals X. And 27 minus 18 is equal to 9. And so what this tells us is that Jamal has to add 9 purple socks. And so this corresponds to answer choice B.
Great. On to question 14. So question 14 says that there are 20 cities in this county of Newton. Their populations are shown in this bar chart. And the average of all the cities are indicated by a horizontal dashed line. So if you can see it, it's right here, right across this bar graph. So which of the following is closest to the total population of all 20 cities? Oh my goodness. Okay. So looking at this bar graph, we can see that the dashed line is right between 4, 5, 0, 0 and 500. So it's between 4,500 and 500. So we're kind of expecting our answer to be something in the form of this. So since this was our average, we also have 20 towns, right? Awesome, yes. As someone in the chat said you multiply the average by 20. So this will be our population, and we multiply 5,000 by 20 as well. So evaluating both sides, we'll see that the lower bound of our population is around 90,000, and the upper bound is around 100,000. Okay, so now let's look at our answer choices. Our answer choices are 65,000, 75,000, 85,000, 95,000, and 105,000. So just looking at this inequality and the answer choices, we would expect that the population is 95,000. And this corresponds with option D. Awesome.
All right, so now we can move on to question 15. So in question 15, we have, suppose 15% of x is equal to 20% of y. And we want to find what percentage of x is y. So the first sentence in the question is an equation. And so we can write down this equation. And basically, notice that 15% is the same as multiplying by 0.15. And 20% is the same as multiplying by 0.2. And so what this tells us is that 15% of x is equal to 20% of y. And so 0.15x, where the x is the x variable, not the times symbol like it is here, is equal to 20% of y. And so now using this equation, we need to figure out what percentage of x is y. So let's call this percentage p, and we want to find p. And so notice that if we want to find p, we have to translate that last sentence. The last sentence essentially tells us that p% of x is y. And so p% is p over 100 of x is equal to y. And so now, using these two equations, we want to figure out what p is. So it might be kind of weird, right? Because we have two equations and we have three variables. And so that you feel like that might not be enough. So one thing you can notice is that we have an x and a y here, and we have an x and a y here. And so we could try to get this first equation to look like the second equation. And so one way that we can do that is if we look at the right side here, 0.2y turns into y. And so how do we get it to do that? Well, we divide by 0.2. So we divide by 0.2. And so that makes the 0.2y turn into y. And well, what does that make this side turn into? That means that we have y, because we divided by 0.2, is equal to 0.15 divided by 0.2 of x. And so these two equations tell us that these two fractions, p over 100 and 0.15 over 0.2, if you multiply either of those two fractions by x, you get y. And so what this means is that these two fractions have to be equal. So we have p over 100 is equal to 0.15 divided by 0.2. All right, so now we have an equation in just one variable. So in order to solve it, we have to isolate this variable. And one way that we can do this is just multiplying by 100 on both sides of the equation. And so what this tells us is that p is equal to 100 times 0.15 divided by 0.2. And so 100 times 0.15 is 15, and we're dividing by 0.2. And 0.2 is 1/5, right? So 15 divided by 1/5 is the same as 15 times 5, and this is 75. So 75% of x is equal to y. And so this corresponds to answer choice C.
Awesome. Karthik, I think someone had a question in the chat that is, what if x is 0?
Well, that's an interesting question. So if x is 0, then y would also be 0. So any percentage of 0 would be 0. but we don't know that x is 0. X could be something other than 0, and if x was something other than 0, we would have to have 75%.
Yeah, essentially, like the AMC expects one answer. So if it was 0, you would have to choose all the answers, which kind of breaks the whole system here.
Yeah.
Awesome. But on to the next question, question 16. This one reads, each of the points A, B, C, D, E, F in the figure represent a different digit from 1 to 6. So each of the 5 lines passes through some of these points, and the digits along each line are added to produce 5 sums, for 1 for each line. The total of the 5 sums is 47. What is the digit represented by B? Okay, so we have all these like lines crisscrossing everywhere, but what is so special about point B? Ooh, I think someone said it in the chat through their equation, and they noticed that B is actually crossed 3 times. If we check all the other points, we can only see 2 lines that pass through it. So just looking at A, right, we have the line over here, okay, and a line over here, and they cross like this. But looking at point B, we see kind of the trails of 3 lines. So that gives us a start to how we can answer this question. So I like to say that the variables here are going to be A, B, C, D, E, and F. And we can write a quick equation that summarizes everything that's going on. So we have 47 as the sum of the total for the 5 lines. And we have each of the other points getting passed through twice. And finally, B is passed through thrice. So awesome. So we know that A through B have to be 1 through 6. So what is A plus B plus C plus D plus E plus F? Can someone tell me what this sum might be? Awesome, yeah. So since we know that they're 1 through 6, they must be the sum of the numbers 1 plus 2 plus 3 plus 4 plus 5 plus 6. If we evaluate this, that means that we'll get the sum of 21. Awesome. And I see that in the chat from our audience. Great job. So let's see how we can put this into our equation. If we rewrite the equation, we actually see we have A plus B plus C plus D plus E plus F, and that quantity is multiplied by 2 plus B. And this makes us quite happy because right away we can solve for B right here. So plugging in 21, we have 47 equals 2 times 21 plus B, and 21 times 2 will be 42 equals 47 plus B. So quite clearly, B will equal 5, and this corresponds to option E. Great job, guys.
All right, so now we can move on to question 17. And question 17 says, how many factors of 2020 have more than 3 factors? So as an example, 12 has 6 factors, 1, 2, 3, 4, 6, and 12. So it might not be clear here which factors of 2020 have more than 3 factors. And first off, it might not be clear what are the factors of 2020. So let's start there. Let's start by listing all the factors of 2020. And so one way of doing this is by finding the prime factorization of 2020. And so what this means is that we split 2020 up into a bunch of primes. So for example, in 12, the prime factorization of 12 is 2 times 2 times 3, or 2 squared times 3. So for 2020, so a lot of you guys notice that 2020 is even, right? Because the last digit is 0. And so we can sort of factor out this 2 here. And notice that we can factor out the 2 again, right? Because the last digit is still 0. So if we factor out 2, we'll be left with 505. And now with this 505, we can factor out a 5, right? Because the last digit is 5. And by divisibility rules, this number is now divisible by 5. So we factor out a 5. We'll be left with 101. And so the question is, are we done here? Is 101 prime? The answer is yes. And the reasoning for this is that 101, you only have to check up to the square root of 101, which is around 10. So we only have to check 2, 3, 5, and 7. And if you check these 4 prime numbers, you'll see that none of them divides into 101. And so we're done here. On prime factorization, if we read off our tree, are the circled numbers. 2 times 2 times 5 times 101. All right, so now let's see using this, what are the factors of 2020? So, all right. So just as a reminder, we found that 2020 is 2 times 2 times 5 times 101. And so what this means is that this is the same as 2 squared times 5 times 101. And so we can start by listing the factors in pairs. And so what I mean by this is, let's start with the first factor, 1. And so the pair would be the number which you multiply by 1 to get 2020, which is 2020. And so the next factor is 2, and that factor pair would be 1010. Then 3 doesn't divide 2020, but 4 does. So we have 505. And then 5 divides in 2020. We have 404. And then notice that 6, 7, 8, and 9 won't divide because we don't have enough primes here, but 10 does. And we'll have 202. And now the last one might not be clear, but notice that we are just essentially grouping up all of these primes into 2 groups. And so for example 1, we left one group empty and the other group containing all the primes. For 4, we had one group with just this 2 squared and the other group with 5 times 101. And the 10, we grouped 1, 2, and 1, 5, and the other grouping 1, 2, and 1, 101. And so the last pair will be if we group this entire 2 squared times 5 and the 101 by itself. And so this will correspond to 20 and 101. So these are all the factors of 2020. And well, how many of them are there? Well, we see 1, 2, 3, 4, 5, 6 rows, each with 2 columns. So there's 12 factors. And now let's see how many of them let's see, we want to find the number of them that have more than 3 factors. So for example, 4 will not cut it because 4 only has 3 factors. All right, so let's start from the left side because the left side seems like it'll have a lot less factors than the right side. So 1 doesn't work, right? Because 1 only has 1 factor. 2 only has 2 factors, 1 and 2. 4, as we said, only has 3 factors. 5 has 2 factors, 1 and 5. 10 is okay because 10 has 1, 2, 5, and 10. 20 is also okay. 101 is not okay because the only factors are 1 and 101. And I claim that the rest of these guys will all work. And so the reason for this is that if a number has 2 factors, it has to be the number and itself. So this means that the number is prime. None of these guys fall into that category because they're all a group of 2 or more prime factors. And if a number has 3 factors, well, it has to be the number, or 1, the number, and some number in between. But how are we going to, what number can we multiply by this number in between to get our n here? Well, that number has to be itself because we don't have any other factors to play with in our factor pairing. So it has to be the square of a prime number. So for example, 25 has 3 factors. And none of these guys fall into that category either. So what that means is that we have 1, 2, 3, 4, 5 that are in this line right here, 6, 7. We have 7 factors, and 7 factors of 2020, all of which have greater than 3 factors, and this corresponds to answer choice B.
Great, awesome. On to question 18. So question 18 says rectangle ABCD is inscribed in this semicircle with diameter FE. So let DA equals 16 and let FD equals AE equals 9. What is the area of ABC? So upon looking at this question, my first instinct is always to connect the center of any circular region with points on the vertices. So I would connect the center, let's call it O, with the vertice C. And just for kicks, I'll connect OB as well. So what exactly is the radius? Can someone help me figure out what the radius might be? And how might we see what the radius is going to be? 17, awesome. Ooh, a lot more, awesome. Right, and someone gave us a line of thinking in which we can add up FD, DA, and AE, and that will give us 16 plus 9 plus 9, and we want to divide that by 2 because it's a diameter, and this will end up giving 17. Awesome, nice job, guys. So we know that OC is 17, and we also know that DO is exactly in the middle of DA, so DO equals 8. Something fishy is happening here. Because again, we're given that ABCD is a rectangle, so we actually have a right angle. Wow, that means that we must have some sort of right triangle or Pythagorean theorem, right? Yes, exactly as Vimeo said. So let's try and find what CD is. What Pythagorean triple would have 8 as one leg and 17 as the hypotenuse? Yes, 15. So we can quickly confirm that 17 squared, which is 289, will be equal to some length CD squared plus 8 squared, right? And 8 squared is just 64, so we'll end up with CD squared equals 289 minus 64, which gives us 225. Awesome. And just quickly checking our squares, we know that CD will equal 15. Nice, so now we're all set up to find the area of this. If we have AC equals 16 and we have DC equals 15, the area of our rectangle will just be 16 times 15. And quickly calculating this will end up being 240, which corresponds to answer choice A. Nice, yes, all of you are following up in the chat. Great.
All right, so now we can move on to question number 19. We're almost at the last 5. It felt like we zoomed through this. So let's reach the end. So we have a number is called flippy if its digits alternate between 2 distinct digits. For example, 2020 and 37373 are flippy, but 3883 and 123123 are not. And we want to figure out how many 5-digit flippy numbers are divisible by 15. So one thing that we can do is we can imagine our 5 digits to be like this. And if we have our first digit here, if that's like, if that was A, then our second digit was B, then by the flippy property, then we have to have A, B, A, B, A, right? Because it alternates between A and B. And this number is divisible by 15. So if this number is divisible by 15, a lot of you guys are noting, this number has to be divisible by 3 and 5. That 5 is pretty interesting. So the divisibility rule for 5 tells us that the last digit has to be divisible by 5. And so if our last digit is divisible by 5, can someone tell me what A has to be? Yeah, so A has to be equal to 5. right? Because A is our final digit, and the only digit divisible by 5, well, besides 0, and 0 doesn't make sense here because our first digit is also A, right? And so if our first digit is A, then we can have a first digit of 0, right? And so what this means is that A is equal to 5. So our number is of the form 5b, 5b, 5 for some digit b. And we know that this number is also divisible by 3. So, as some of you guys have already said, then we must, for the divisibility rule of 3, we have to add all of our digits here and see if that's a multiple of 3. And so if we add all of our digits here, we have 2 b's, right, which corresponds to 2b, plus we have 3 5's here, right? And 3 times 5 is 15. And so if 2b plus 15 is a multiple of 3, well, notice that 15 is already a multiple of 3, right? And so if this guy is a multiple of 3, let's say 3k, right? Then if we subtract by 15, then we have 2b is 3k minus 15. But we can factor out a 3 here, right? And so what this means is that 2b has to be a multiple of 3 as well. And so if 2b is a multiple of 3, then b itself has to be a multiple of 3, right? Because 2 doesn't share any factors with 3. So we figured out that b has to be a multiple of 3. And so some of you guys are saying 3, 6, and 9, right? However, there is one digit that we're forgetting. Don't forget about 0. Don't forget about 0. 0 is also a valid digit, and it is a multiple of 3. So we can't ignore it here. So, as a lot of you guys have said previously, we have b can either be 0, 3, 6, or 9, and all those digits work. And so we have 4 numbers here. And a was already chosen. So we only have 4 numbers, and this corresponds to answer choice B. Quite fitting. All right, great job, everyone.
Nice. So let's move on to question 20. So this one reads, a scientist walking through a forest records integer heights of 5 trees standing in a row. Ooh, okay, integer heights. She observed that each tree was either twice as tall or half as tall as the one to its right. Unfortunately, some of her data was lost when rain fell on her notebook. Her notes are shown below with blanks indicating the missing numbers. Based on her observation, the scientist was able to reconstruct the lost data. What was the average height of the trees in meters? Awesome. So just starting off this problem, a lot of you noticed that tree 1 and tree 3 must be 22 because we were given in the conditions that a scientist recorded integer heights. So let's just mark that in for something that we know. And now let's continue. So for tree 4, we can either have 11 or 44. Okay. And then for tree 5, our decision depends on that. So let's see what happens if tree 4 was 44. Whoa, someone put a huge explanation in the chat. But let's continue with this. So if our tree 4 was 44 meters, that means tree 5 could either be 22 or it could be 88. Now, looking at the answers are all between 20 and 40. If I were to have a tree that was 88, that would pull our average up so much, and we might not even get an answer between 20 and 40. But let's just check. So if our scenario was 44 and 88, that means we would have had 11 times 2 plus 1 plus 2 plus 4 plus 8 as our total height, right? And we need to divide this by the number of trees possible. So that's going to be 5. And if we see this, we'll add them up and eventually get 11 times 17 over 5, or 187 over 5. And of course, just looking at this number, it's going to be way more than 150 over 5, which is 30. But it's a little bit smaller than 40, so maybe there's a little bit of hope here. But we'll just confirm what this number ends up being. So if we do subtract, or divide, we get 3, and then we get 7. Ooh, okay. So this number ends in 0.4, and in the table we were given that the number ends in 0.2, right? Awesome. Me pointed out that it doesn't end in 0.2. So 88 is not what we're looking for. Let's try 22. Okay, so if we try 22, our next option will be 11 times 2 plus 1 plus 2 plus 4 plus 2 over 5. And let's see what this will evaluate to. So we'll have up in the numerator 1 over 5. And this will give us 4. Ooh, sorry. This will give us actually 2. And then we'll have 4.2. Awesome. So this actually turns out to be one of our answers. And we actually got a little bit of luck here, in which we tried 44 and 22 right away. Another thing that we could have tried, as a lot of people pointed out, is just quickly realizing that maybe the end won't be 0.2. Something that might help is the fact that we could also evaluate this fraction by multiplying by 2 and then dividing by 10. So essentially we've multiplied the numerator and the denominator by 2. And we'll see that this becomes 242 over 10. And this is just a quick way that I like to see what 0.2 will evaluate to when you're dividing by 5. And yeah, that's my quick tip on if you were to end up evaluating the other options. Okay, and finally, just to wrap it up, 24.2 will end up being option B.
All right, so now we're on to question number 21. We're finally in the final 5. So in the picture, we have a game board of 64 squares. As you can see, it alternates in color from, well, in the question it says black and purple. On the picture here, it's orange and white. And so the figure shows a square marked P, which is right here, and it's at the bottom row, and square Q, which is right here, right? And that's on the top row. And a marker is placed at P, and we want to move up the grid, and we want to see how many ways we can go from P to Q in 7 steps. So, for example, if we go from this P right here to this square, the next circle, that's 1 step. The next circle, that's another step. 3rd step, 4th step, 5th step, 6th step, and 7th step when we finally reach Q. So we want to find out the number of these types of paths. So the first observation is to note that we can't waste any steps. For example, we have to cross every row, right? At least once to go from the bottom row to the top row. And so we have to go through 7 rows, which means we'll need exactly at least 7 steps. And so we're only given 7 steps to work with. So that means that we can't waste anything by going backwards or away from Q. So every step that we take has to be towards Q. And so, for example, one way that this can be helpful is, for example, if we reach this square right here, that would be bad, right? Because that would require 4 moves. But then when you reach this square, in order to get to Q, you have to backtrack somewhere. Because if you try to go as close to Q as possible, you'd only end at the orange square that's to the left of Q, which is not good enough. And so what this means is that we cannot go anywhere outside of this region. So this region right here, I'll just complete the region. This region tells us that if we go beyond this region, then we're wasting steps. We're going away from Q, and that's not a good thing. And so we now need to figure out how many ways are there to stay in this region and reach Q in exactly 7 steps. So one way of doing this is by marking the square. Marking the square is a longer path by the number of ways that we can reach that square. And then eventually we'll hit Q, right? And we'll figure out how many ways are there to reach Q. So what I mean by this is, let's look at this square, right? This square from P has exactly one way of reaching it. You just go, northwest. Yeah, northwest. So that has one way of reaching it. And similarly with this square right here, there's only one way of reaching it. And we can continue this idea. So if we look at this square right here, then this has one way of reaching it. You have to start from this square that's right below and then move up here. Now, let's look at this circled square right here. There are now two ways of reaching it, because you could have either reached it from the 1 on down here or the 1 down here. And so that means there are two ways of reaching it. This square, again, only has one way of reaching it because we had to come from this square. And so now we can continue this idea by seeing that any square is equal to the sum of the numbered squares below it. So for example, we got this 2 by looking at the sum of the numbered squares below it. And so we can just apply this logic and we can complete the table relatively quickly. So for example, this square right here, this has to be a 1. This square right here, it's above a 1 and a 2. So this has to be 3. There are 3 ways of reaching this square. This square right here, again, it's under a 1 and a 2. So this has to be 3. This square right here, it's underneath a 1 and a 3. This is a 4. Here's a 3 and a 3. So this gives us 6. This square right here on the edge only has to come from the 3. So we can add the two numbers below and continue like this. This 4 and this 6 combine together to give a 10. This 6 and this 3 combine together to give 9. This 10 and this 9 combine to give 19. And this square on the edge has to come from the 9, so it's also 9. And finally, our Q square up here is the sum of 19 and 9. And so the square labeled Q has exactly 28 ways of reaching it. And this corresponds to answer choice A. All right.
Awesome, yes. So now let's move on to question 22, which has a lot of words and a lot of symbols. But although it's question 22, I think we got this. So let's start reading it. So it starts, when a positive integer n is fed into a function f, the output is a number calculated according to the rule shown below. So it's actually shown through this really nice function machine. For example, if you start with 7, the function will input 7 and output 3 times 7 plus 1, which equals 22. Then the output is repeatedly inserted into the machine 5 more times until the final output is 26. Okay, so what if we do this again? The same 6-step process is applied to different starting values of n, and the final output will become 1. What is the sum of all integers n such that this will happen? Okay, wow. I think a lot of people have also noticed that the even part of this, right, 3n plus 1, is something related to the Collette's conjecture. This is a really cool part of math that no one yet has proved, but maybe it's something that you guys will end up proving. Who knows? So let's continue and see if we can try and work backwards with this problem. So if we end up with 1, that means that either n divided by 2 was 1 or 3n plus 1 was 1. However, since n was a positive integer, this right here cannot be true with a positive n, right? So our only option was to have had an even n. So I'm going to say that 1 was our final and 2 gave us 1. Awesome. Now let's evaluate 2. We have now that 2 equals n divided by 2. Or we have 2 equals 3n plus 1. Again, we can use a similar argument here, right? If n was a positive integer, then we couldn't have had something that was 2 because the minimum is 4. Awesome. So that means that 4 must have given us 2. Wow, it doesn't seem so hard yet. And we're pretty happy that the first few steps are kind of determined like this so that we have less probability. But maybe something will start changing up here. So 4 equals n divided by 2. Okay, that seems reasonable. 8 seems like a possible solution. And now this part starts becoming viable, right? We can have an integer n, more specifically 1, equal 4. So that will just increase the number of options. So either we had 8 go into this function, or we had 1 go into this function. Okay, so this was kind of blank number 6, and we had blank number 5 at this level, 4 at this level, and 3 at this level. And we want to find what blank number 1 was. Okay, now let's look at this. I'll just evaluate this side of the branch first because we actually know what's happening, right? We kind of iterated it up here with 1, 2, and 4. Yeah, as Vimeo said, 1 just goes back to the ones that we've already solved. So we already know that this path will look something like this. And this will be kind of blank 2, and this will be blank 1. All right, so we found our first n, but we need to continue on this side, right? So let's continue on where our path diverged. So if we had an output of 8, what could have been our inputs? Looking at this, we have n over 2 is 8, which gives us 16, and that seems reasonable. But now let's look at the other one. 3n plus 1 equals 8. If we start solving, we'll get a fraction, and that's not quite possible with this because each of our outputs will be integers. So this actually doesn't give us another solution. And that's all that we have for the second level. Awesome, me figured out that n would have had to been 7 over 3, and we can't input that into our function. Okay, and then finally we have 16. So the first branch seems very viable. If we have n over 2 give us 16, we know that n must have been 32. And finally, if we had 3n plus 1 equals 16, that would have given us what number? Guys, what number times 3 plus 1 equals 16? Awesome. We have 5 times 3 plus 1 equals 16. So 16 is one of the possible options. Okay, and then finally, we wanted to solve for the sum of all integers, right? So if we evaluate this sum, we'll get something like, actually, are we done? Are we done? Four plus 5 plus 16. 25. Close. So we're actually not done. This is actually the first blank, right? But we wanted to find n. So we actually have one more level to go. So let's see. We want the nth level. And we only found blanks 1 through 5. Okay, so let's see. If we had n, we evaluated that option up here. So 4 gives us either 8 or 1. So n is going to be either 8 or 1. Awesome. And what can 16 be? Ooh, sorry, I wrote 16 here, but I meant. So what can this 5 be? 5 will either be 3n plus 1, but that's not possible, or it could be 10. So this level here, this will be 10. And finally, we have 32. So let's look at this decision. Is it possible to have some odd number such that 3n plus 1 equals 32? No. And I agree. So if we try to evaluate this, 3n equals 31, and there's no such integer such that this is true. So we're only left with 62. Okay, now we are very close. So now all we have to do is just add these up. So 1 plus 8 plus 10 plus 64 will give us 83. And that will be answer E. Nice. Thanks for the hype, Warrior Cats.
All right. So now we can move on to question number 23. So in question 23, we have 5 different awards that are given to 3 students. Each student will receive at least 1 award. And we want to find out how many ways can the awards be distributed across these 3 students. So we have 5 different awards, right? Let's give each of them a name, right? Let's say their awards are A1, A2, A3, A4, and A5. So these are our 5 awards here. And we have 3 students. Let's give them a name. Let's say Alice, which will say A, Bob, and Carl, right? So we have 3 students and 5 awards. And the only restriction is that each student cannot be left empty. They have to have at least 1 award. And so if each student has to have at least 1 award, we have, let's say the first student receives X awards, the second student receives Y awards, and the third student receives Z awards. We know that each of these guys has to sum up to 5, right? Because that's all of our award totals. Sure, we can call them Andy, Becky, and Carlos. So if we have 3 numbers that sum to 5, or 3 integers that sum to 5, and all of them are greater than 1, what can these integers be? Yeah, so some of you guys are mentioning stars and bars. So stars and bars would work here if our awards were all identical. So we had to have like 5 identical awards in order for us to directly apply stars and bars. Yeah, so if we have 3 numbers that sum to 5 and all of them are 1, well, our only combination is some combination of 3, 1, 1, some permutation of 3, 1, 1, or 2, 2, 1. Sorry, 2, 2, 1. All right. Oops, there we go. So 2, 2, 1. We can't have any other combinations of 3 numbers, all of which are at least 1, and with which sum to 5. Because if we use a 4, let's say like x is 4, right? And that means y and z both would sum to 1. And y and z can't be both at least 1, but sum to 1. That doesn't make any sense. So we have to have one of these 2 guys. So let's break it up into 2 cases. So let's call our first case our 311 case, and our second case our 221 case. So don't worry that we're doing casework here. Our cases won't actually be that bad to compute. So let's start with our first case, 311. So notice that 311, well, 311, we don't know which order of 311 it's in. So for example, Alice could have been the one that receives the 3 awards, or it could have been Bob, or it could have been Carl. We don't know. So let's give them so let's find out how many ways are there to distribute this award count. So if we have 311, the number of permutations of 311, can someone tell me what the number of permutations of 311 is? Or how many ways we can give Alice, Bob, and Carl 3, 1, and 1 awards? Not ignoring the fact that the awards are distinct. Just look at the counts. So the Warrior Cat says 6. So that's really close. But remember that the 1 and the 1, without counting the awards, the 1 and the 1 are the exact same, right? So we have to do one more thing to that 6 in order to make it exactly what we need. So yeah, so 3 is correct. So 3 is correct since the 1 and the 1 are the same, so we have to divide that 3 factorial by 2. Or if you want another way of seeing it, then we have to figure out which of Alice, Bob, and Carl gets the 3 awards. So there are 3 ways of choosing whichever Alice, Bob, and Carl gets the 3 awards, and the other 2 will get 1 award. So let's start with 3. Now once we've assigned, let's say Bob is the one who gets the 3 awards, right? And Alice and Carl both get 1. So Alice gets 1 award. And so how many ways are there for Alice to pick the award that she'll get? So she can pick 1 of the 5 awards. So how many ways are there for her to do this? That's rude to Alice and Carl. Yeah. Well, there's 2 other cases where Alice gets 3 and Carl gets 3. So don't worry about them. Yeah, so there are 5 ways of picking which award Alice will get. So Alice can get 1 of these 5 awards. So now once Alice picks her award, let's say she picks award 2. That is off the table now for Bob and Carl. They cannot pick award 2 anymore. So now Carl, let's look at Carl's perspective. He can pick 1 of these 4 guys, right? And by the same logic, since we have 4 awards and 1 of them must go to Carl, we have 4 ways of giving which award that we give to Carl, right? And so let's say Carl picks award 4. Then the remaining 3 awards have to go to Bob. And so this case is done. And so this corresponds to 3 times 5 times 4, which is, well, 3 times 5 is 15, and times 4 is 60. All right, so that's our first case. So now let's look at our second case, our 2-2-1 case. So in our 2-2-1 case, we have a little bit of nuance here. So again, we have 2-2-1, and we need to pick whoever gets the 1 award. In fact, the 2-2-1 case, the first step of picking like the order is the exact same as a 3-1-1 case, because the 3 is like a 1 here, and the 2 1s are the 2 2s. So we need to pick whoever gets the lone award. And so let's say we have 3 ways of picking who gets this award. And let's say this person, since Bob got all the awards last time, let's say Bob gets only 1 award this time, and Alice and Carl both get 2. So now that Bob only gets 1, then now the question is, how many ways are there of distributing the 5 awards again? So here, we need to pick which award Bob will get, right? And in this case, our awards 2 and 5 are, sorry, awards 2 and 4 are now able to be chosen because this is just a second case, right? So we need to pick how many ways Bob can pick 1 award out of the 5. So Bob has 5 ways of picking the award that he chooses. So this is 3 times 5. So far, so good. So let's say Bob picks award 3. Now, Alice and Carl have to pick 2 each out of these 4 awards. Now, this is a little bit tougher. So in order to figure out how many ways they could each pick 2 awards, well, notice that, look at Alice's perspective. The number of ways she could pick 2 awards, well, we can actually just list it, right? She can pick awards 1 and 2. She can pick awards 1 and 4. She can pick awards 1 and 5. She can pick awards 2 and 4, 2 and 5, and 4 and 5. And if you didn't want to list this, we'll notice that Alice has 4 choose 2 ways of picking her awards. Again, 4 choose 2 is she picks her first award, 4 possibilities. She picks her second award, it only has 3 possibilities this time because she's already picked her first one. And we divide that count by 2 because picking awards 1 and 2 is the same thing as picking awards 2 and 1. So we have 6 ways of picking stuff up here. Remember, we have to divide by 2 because picking awards 1 and 2 for Alice is the same thing as picking awards 2 and 1. There's nothing different about these scenarios. So we shouldn't double count them. So now 3 times 5 times 6. 3 times 5 is 15 times 6 is 90. And now all we have to do is add up these two numbers from our 2 cases. So 60 plus 90 is 150. And this corresponds to answer choice B.
Great. So on to the final 2 questions. Now we have question 24. This one reads, a large square region is paved with n squared purple square tiles, or in this case, white square tiles, each measuring s inches on the side. Okay, so I will denote that right here, s. And a border of d inches surrounds the whole tile. The figure below shows the case for n equals 3, but when n equals 24, there are 576 purple tiles covering 64% of the area. So what is the ratio of d to s for this larger value of n? Okay, wow. So let's try and figure out what the area of each of these are, and then we can try and figure out what the ratio is. And again, we're not solving exactly for d and s, we're solving for the ratio. So if we do end up with one equation or one relationship, we shouldn't get too worried because, again, we're not solving for the variables exactly. So let's start. How would we represent the area of just the white squares in this diagram? What would be the numerical representation in terms of S for the area of the white? Okay, maybe what will help us is the problem told us there are 576 of such squares, right? And awesome, daily challenge put into the chat that the area of one square would be s squared. So if we have 576 of these, that means that the total area of the purple, or in this case the white, will be 576. Awesome. So, what does this mean for the rest of it though? So we want to find what is our total area. How can we find the total area? Well, first we have to figure out what exactly is the total side length. And okay, I misinterpreted the question. So D is actually going to be this small region right here between the squares. So this will be D. Awesome. People are putting very interesting facts. I agree, knowing squares from 1 squared to 24 squared is pretty helpful. But what would the whole border be? What would this huge side length right here be? Okay, well, just looking at this case of 3, we have a little border here, D, plus S, plus another D, plus S, plus D, plus S, plus D. So in this case, we would have 4D plus 3S. And notice that we had n equals 3, so maybe there's something going on here. If we had, for instance, 24 squares, square, 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 more squares, how many gaps would be between these objects? Well, there would be 23 gaps of D. And we know this because what I like to imagine is a huge loaf of bread. And if I make one cut, I'll have 2 parts. And if I make 2 cuts, I'll have 3 parts. So essentially, if we have n parts, there's going to be n minus 1 spaces or cuts. And finally, we have to include the n's because in the picture and our n equals 24 case, there's going to be a little bit of space at the ends. So finally, writing the border for our n equals 24 case, we'll have 24s plus 25d as our side length. Finally, we can start setting up our relationship. So we have 576 s squared over 24s plus 25d squared equals 64%. So because this isn't a fraction, I'm going to write the rest of the percentage as a fraction. Okay. Now, this is kind of hard to evaluate just on its own, but something slick we can try is actually taking the square root of both sides. And this allows us to kind of simplify because we know s and d are going to be positive. And so we won't have to worry about any of those icky sign error things that might happen. So taking the square root, we'll get 24s over 24s plus 25d equals 8 over 10 or 4 over 5. Okay, so let's solve this. So we'll get 120s equals 24 times 4, which is 96s plus 100d. Then moving it over to the other side, 24s equals 100d. And we want the ratio of d to s. So let's finally finish this off, and we'll get d over s equals 24 over 100, and this divided by 4 on the top and bottom will be 25 over 2. And, it will be 6 over 2, 25. Awesome. The fact that the answer choice of 2 over 25 was not on the answer choices saved me there. But this will give us option A.
All right.
Nice.
All right, so now we're going to go on to the final question. So in this question, we have a bunch of rectangles and a bunch of squares. So we'll see rectangle 1, rectangle 2, and squares 1, 2, and 3. And they combine to form a big rectangle, so you see on this outline, that is 3,322 units wide. So the width is, this width here is 3,322 units. And the height is 2020. And so we want to figure out what the side length of this middle square, S2, is. So it feels like we don't have enough information to solve our problem. But, well, when it feels like we don't have enough information, the simplest way to gain information is just to build equations, right? And by building equations, we can maybe figure out more about our situation here. So the first piece of information that we can use is use the fact that all 3 of these guys are squares. So we can label the side lengths. So let's label the side lengths as A, B, and C. We don't know that A and C are equal, even though it looks like they are, so we can't assume that right away. So now with this A, B, and C, let's see if we can build some equations using this 2020 and 3322. So first off, notice that if this side length is B here, and this side length is c, then they combine together to form this side length of b plus c. And even better, notice that this b plus c here, this combines with the a to get a plus b plus c. But this is really good news because we know what this side length is. This big side length is 3,322. All right, that is one equation down. Now let's see if we can build something with this 2020. So Panda A already looks like they have an equation. So let's see. So in this case, we have this 2020, which consists of this side length of A plus this small side length of the rectangle that we don't quite know just yet. So in order to get that side length, let's look to the other side. So if we look over here, this is B. This side length is B, right? Because it's the side length of square S2. And this big side length is C. So from here to here, this is C. And so this big side length is C, and this small side length is B. This is the difference between C and B. So like if we look at the contribution of C and we subtract out the contribution of B, we get this side length. So this side length is C minus B. And so since this is C minus B, since this is a rectangle, we can move it over here, get C minus B. And now we're very close. We have an A and we have a C minus B. And we can add those two up to get A plus C minus B is equal to 2020. All right, so now we've been able to build up two equations using these two side lengths. And it seems like that's all we can do. So let's see if we can work with these two equations, because these two equations have to be special in order for us to be able to solve for B. Remember, we're solving for B, the side length of S2. So now in order to solve for B, we see a B here and a minus B here. So, is there any way we can get rid of A and C? What can we do with these two equations in order to get rid of A and C? Yeah, so as Daily Challenge says, we can subtract the two equations. So if we take the first equation minus the second equation, notice that the A term just cancels out, which is quite amazing. So the A term cancels out and the C term cancels out, and conveniently, we're only left with B terms. So we have B minus negative B. So if we subtract the negative B, that's the same thing as adding B. So this is 2B. And this is equal to this difference between these two guys. So the difference between these two guys is 1302. So now we have, miraculously, we've ended up with the equation with only B's in it. And now we have 2B equals 1302. And now in order to solve for B, all we have to do is divide by 2. So once we divide by 2 on both sides, we'll end up with B is equal to 651, which corresponds to answer choice A. All right. Yeah, so we've finally reached the end of our 2020 AMC 8.
I feel like this deserves some type of celebration. So if you guys did enjoy this, put an exclamation mark in the chat. And I'm gonna do this too because I really enjoyed working with you guys and Karthik. Yeah, you guys are really
you guys
wonderful.
were all great.
Awesome. Thank you guys so much for coming. And this is actually the end of our live solve. But if you do have questions, feel free to stick around for a little bit and we'll try to answer them the best we can. But yeah, thank you guys so much.
Yeah, thank you all for coming.